Hi, let's talk once again about dynamic components in Angular and the role of the NgComponentOutlet directive in this topic. In short, this directive offers you an alternative way to create components dynamically in Angular compared to the method I showed you in the previous video. Today, you will learn how to utilize this directive to create or destroy relatively complex components that have inputs and content projection. Besides that, we will dive into the source code of this directive and learn a bit more how it is designed and how it is working. Also, we will expose limitations this directive has, and in the end of the video I will show you real-life use case for dynamic components in Angular when we will be creating Angular components from JSON config. If it is the first time on my channel, my name is Dmitry and my goal is to help you to become an advanced Angular developer who understands Angular in depth and develops applications consciously knowing how things are really working. My channel is already full of unique and advanced Angular tutorials, which you can check out later, but now let's continue and learn more about NgComponentOutlet directives. Alright, let's get started with basics and let's learn how to create and destroy components dynamically with NgComponentOutlet directive. Currently you see the old approach I showed in the previous video. Here we create a view container ref where the component has to be created, and when the component has to be rendered, we call the createComponent method with a component class constructor as an argument. Once we need to destroy the component, we call the corresponding method called destroy. This is so-called imperative approach, when we explicitly define each step of component creation, like getting or creating a view container, calling this certain method, updating this certain inputs, and so on. Saying simpler, we define how to create a component. The NgComponentOutlet directive allows you to skip these exact steps, these exact instructions, and focus more on what needs to be created. In practice, it looks like the following. First, let's remove everything that is related to the previous imperative example. So we don't need the view container anymore, right? So we can remove it. Here we go, and we are ready to go. And now we have to perform two simple steps actually. We have to import the NgComponentOutlet directive, obviously, right? And then we have to apply this directive to the element next to which one the dynamic component has to be eventually created. And as an argument for this directive, we have to provide the class constructor of the component that we want to create. Unfortunately, I cannot define it directly in the template, so we have to create a certain property and define the value like that. And then obviously we have to deliver this property value to the componentOutlet directive input. If we save this change, you can see that the widget component has been successfully rendered. And if you want to destroy the rendered component, you have to provide value null for the NgComponentOutlet directive input. As easy as that. So now if you try to click the destroy component button, you can see that the component is successfully destroyed, which is exactly what we want. If you don't want an immediate component creation, you can of course set the initial value for this property to null and then just assign the component class constructor a name only when the user clicks the create button component also, right? Now, you might probably have noticed that instead of the proper title and description, the widget has placeholder strings. This is something that we can configure by the corresponding inputs of the widget component. So let's learn how we can update inputs for the component that has been created by the NgComponentOutlet directive. This is very easy as well, and the only thing you have to do is to use a special input from the NgComponentOutlet directive named NgComponentOutlet inputs. And there provide an object where the object keys match the component input names, and values obviously will be the values that those inputs should have. And in my case, let's imagine that the title of the widget will be weather, and it has the following description. If you try to test this change, you will see that, okay, the inputs have been successfully updated and everything works as I expect. If you want, you can also assign this object to a dedicated property in the class and just deliver it like that, because most probably in real use cases you would like to change input values later at runtime. So having it like that, you can change input values at any time you need. And as you can see, using the NgComponentOutlet directive, we don't care about viewRef container, we don't care how exactly inputs should be updated or anything like that. We just say, hey, there is the component class, there is the input values it should have, please do the stuff, create me component out of it. This is the declarative approach, and it feels like magic, but under the hood of the NgComponentOutlet directive happens already familiar imperative stuff. So let's take another few minutes to explore the NgComponentOutlet source code. If you watched my previous video about dynamic components, things here must be very familiar to you. Here you can see the already familiar view container ref that is being injected via the constructor, and this will create or reuse the view container on the node where this NgComponentOutlet directive resides. So that's why you don't have to care about view container, this directive cares about it. Then below you can see how it is used to manipulate the view inside the container. For example, if any of these inputs in the directive changes, then the currently existing view container will be cleared, which means everything will be removed, which makes sense actually, because if changes the component class constructor, then we have to destroy the old component and create a new component for the another component constructor, right? Also, you can see here how the create component method is being used in order to create the component instance, and then the reference to the created component is used in order to, for example, update component inputs. So here you can see the same set input method is used to update component inputs. So no magic here at all. Most of the things we used in the previous video, and using that knowledge you can implement your own NgComponentOutlet directive if you want. But let's get back for a while to our project, and let me very quickly show you how you could project content into the component created by the NgComponentOutlet directive. This is actually not so hard and very similar, I would say even identical to how we did it when we were creating dynamic components imperative way. For example, let's imagine that somewhere in the app component view, I have a component that contains the widget information. Right now, I have two issues with this current implementation. The widget content is eagerly rendered even before the widget is actually created, and it is rendered outside the widget. And those are two issues I have to fix, and let's solve them one by one. To delay the creation of the content component, we can wrap it with the special construct called NgTemplate. This will make this part of the view kind of lazy, which means that we have to manually instantiate it at some point in order to render it. Yeah. So for that, we need actually two things. We need to, first of all, get a reference to this template. So for that, let's define a template variable on it. And then using the viewChild function, we can get a reference to this template just like that, using the name of the template variable as an argument. The second part we need is a reference to the view container where this embedded view has to be created. In my case, the view container created for app component should be okay, and I can get the reference to the view container by injecting the view container ref token. Good. Now, having these two parts, I can create the embedded view from the template whenever I need it. Let's say I want to do it when user clicks the create component button, and for that I'm going to use the API of the view container ref, and namely the method create embedded view, which takes as an argument the reference to the content template. Now, when I created the embedded view from the ng template, I have to deliver the DOM nodes of this view to the NgComponentOutlet directive, and namely to the corresponding input that is called NgComponentOutlet content. If you have a look what it takes, you can see that currently this input is purely typed. It takes array of any arrays, but in fact it takes an array of the DOM nodes arrays that have to be projected into dynamically created component. And fortunately, the embedded view instance has a special property that contains those DOM nodes, and it is called root DOM nodes, which is exactly what I need. And I can create a special property in my class, which is let it be empty array by default, and there I will just update this property with the new array that contains the DOM nodes I want to project. After that, the only thing I have to do is to simply deliver those root nodes straight to the NgComponentOutlet content input, and that's it. Now, if I try to save my change and test them, you can see that the widget component is successfully created and projected in the projection slot of my widget. And it looks like it is a full declarative alternative to the less elegant imperative approach. However, the NgComponentOutlet directive has limitations that don't make it a universal solution. Let's cover the most significant limitations of this directive one by one. First limitation is that you cannot have multiple instances of component for NgComponentOutlet. So the only one component instance can be created in the view container ref that is associated with the NgComponentOutlet directive instance. This is, if you remember from the source code, each time before creating a new component instance, the view container ref is cleared, and that's why you cannot have multiple instances. The second serious limitation of the NgComponentOutlet directive is that it doesn't allow React to component outputs created by this directive. It just has no dedicated API for that. However, this might change soon because there is a pull request made by a really fantastic contributor, Matthew Riegler, who has already brought so many cool things to Angular, and I'm a big fan of him and very grateful for everything he does for Angular. And when his pull request will be merged, we will be able to react to outputs for the dynamic components created by the NgComponentOutlet, which is an awesome improvement in my opinion, and I'm looking forward to trying this feature out and share with you my experience in some maybe short video, which I usually share on my other social media profiles, which you can subscribe right now to not miss it in the future. But let's move forward. If you use the Angular version that is older than 16.2, then you would not be able to set inputs for the created component as well, because this feature that I showed you earlier in this video, it is possible to do only with versions 16.2 or newer. The only possible workaround would be providing data to the component via dependency injection and custom parent injector. Then you should also keep in mind that this directive recreates component every time when one of these input changes, which would make sense again, but this is something you should keep in mind and something you cannot control or prevent. This is just how this directive works. So as you can see, even though the NgComponentOutlet directive requires less code, it doesn't give you so much control over the created component instance. And that's why if your use case requires one of the things I mentioned before, then you have to move with the imperative approach of creating dynamic components. Okay, now let's talk about real-life use cases for dynamic components in Angular. In the previous video, you were asking me quite a lot about that in the comments, so this is my bad, sorry. I had to focus more on it because the connection with real-life use cases and proper visualizations, it is very important for the learning purposes and helps to learn faster. However, before we jump to the real-life use case overview, I would like to mention about the learning platform that shares the principles I mentioned before. And this is the sponsor of this video, and it is Brilliant. This is an awesome place where you can learn math, computer science, AI, and programming in different languages like Python. They provide interactive lessons with strong visualizations that help to grasp knowledge much easier and more engaging way. Try everything Brilliant has to offer for free for a full 30 days. Check the video description where you can find a special link, brilliant.org/decodedfrontend. Click on it and you will also get 20% off for the annual premium subscription. And now let's get back to our real life use case. So you need to create components dynamically whenever you don't know at build time which component should be rendered in some certain place of your application. My favorite use case is rendering a component based on some JSON config that you might get, for example, from the server. For example, you want to offer users an option to configure which widgets to display on the dashboard, predefine widget title and description inputs, and then save this configuration as a JSON file somewhere in the database or browser storage, and then restore widgets according to the saved config. I have prepared such a use case in a separate branch, so let me quickly switch to it and guide you through. You can get this example also from the GitHub. The link to this project will be there, so you can switch and investigate on your own. So here I have a JSON file that contains a config. Here you can see the array of widgets that have to be generated on the page, and you can see that each of them contains a key of the widget, and this key will be used in order to resolve a proper component class later at runtime. Also, each of the widgets has predefined inputs, and then in my app component I fetch this JSON configuration using the standard Angular HTTP client. However, when we receive the raw JSON config from the server, it will not be ready for the usage, because JSON config doesn't support data types like class constructors. JSON understands only numbers, objects, arrays, booleans, nulls, and strings. I hope I didn't miss anything. So that's why we have transformed the widget key in the JSON config into the class constructor. And that's why I have this map operator where I transform the config and map the widget key from the JSON config to the corresponding class constructor, which is required eventually for the NgComponentOutlet directive to work. And then already this transformed config can be delivered to the component template, where I use this simple for loop and I simply instantiate the corresponding component from the class constructor I have to provide, and I provide the corresponding inputs for the component that has to be created. And as you can see, my widgets are perfectly rendered and everything works fine. If, for example, the config has been changed at some point, for example, user changed the config, then if we save it and reload the page, you can see that everything will be recreated according to this new configuration. Alright guys, thanks for watching this video until the end. I hope this video was useful, and If it is so, and if you would like to support my work, support my channel, you have many options to do that. The first option I call support and learn. So you can check out one of my advanced video courses about Angular. Some of them are really in-depth and very long. For example, advanced Angular forms, and I'm pretty sure from there you can learn a lot of cool things. Or another option is to support my channel with a little donation on my Patreon. In return, I will be publishing exclusive videos that are covering topics and different tips and tricks that are not included in my current free videos here on the YouTube. If you have been looking for a community of Angular developers where you can get connected with others, discuss different Angular topics, or simply ask your questions, then please welcome to our Discord server. This is absolutely free and we are looking forward to meet you. And of course, each time you leave your comments, each time you share this video with your colleagues and friends, and each time you subscribe to my social media profiles, this is invaluable contribution from your side, which helps my channel to grow and helps me and motivates me to create more videos like this one. Nevertheless, I wish you happy coding, enjoy Angular, thanks for watching, and see you in the next video.